Good day all. Welcome to my course on flow-induced vibration study for piping system. Flow-induced vibration, in short, it is also called FIV study. In recent times, there are many vibration problems are reported, and because of that, every organization and even all design consultancies are trying to implement flow-induced vibration studies during the design stage itself, so that in the design phase itself the probability or causes of piping vibration can be reduced. So because of that, I thought that this will be a good learning if we study about flow-induced vibrations. The main contents that will be covered in this course are: first is introduction, means course objective and who should attend this course. Then next, what is piping vibration? In this section, we will be know that what is causing the piping vibration and what is actually a piping vibration, the definition, or what can we call a piping vibration. Then causes and effects of piping vibration, means what are the main reasons that a piping vibrate, what is causing that vibration, and also the what is the effect, means because of piping vibration what could happen to the piping system. Then we will be coming to our main topic, which is flow induced vibration or FIV. So first we will be defining what is flow induced vibration or what it means. Then what are the reasons for flow induced vibration in a piping system? So what are the factors that induces flow induced vibration in the piping system? Then the steps for flow induced vibration analysis or study that are usually performed in design consultancies. And at the end, we will learn about some mitigation options of the flow induced vibration problems. So we will try to find out that in which way we can reduce the or mitigate the problems associated with flow induced vibrations. Now let's start with the course objective. The main objective of this course is to explain the basics of flow induced vibration in a piping system, means the basic theories what will be helpful to learn a understanding of flow induced vibration. Then to familiarize with the steps required to perform the FIV studies. So we will be learning the steps or step-by-step methods so that we can screen our lines, or what are the steps followed in design consultancies to perform FIV studies. Then to explain some of the mitigation methods. So these are the course objectives. Now, who should attend this course? The course will be suitable for all piping engineers who are associated with flow-induced vibration studies, mainly piping stress engineers, because in design consultancies, the flow-induced and acoustic-induced vibration studies responsibility falls on them, and anyone, any engineer who wishes to learn the basics of FIV studies. So it will be helpful for them to understand the basic concept of flow induced vibration. Now introduction. What is piping vibration? So you can see here that in the right side image, the piping system is vibrating, even though you cannot see that pipe is actually vibrating, but internal fluid or the graphs what is it is generating fast Fourier transform curves is showing that there is some vibration in the system. Now data provided by the UK's health and safety executive for the offshore industry shows that over 20% of all hydrocarbon releases in the UK North Sea are due to vibration-induced fatigue failures. So you can find that most of the failures what happens in any operating plant is a major cause or reason is piping vibration. Data available in various plants dictate that between 10 to 15% means a major chunk of pipework failures are because of piping vibration. This is the reference from a Energy Institute guidelines based on which we usually perform our FIV study or flow-induced vibration studies. So let's first learn what is piping vibration. Piping vibration can be defined as the continuous to and fro motion from an equilibrium position. So it is a oscillatory motion that can be seen. Uh, if you see or refer to the right side image here, you can see that piping system is vibrating. The pipe is completely vibrating with respect to some position, that is usually a equilibrium position. So if you see that in an operating plant this type of motion is observed, so obviously it will be creating a serious integrity risk to operating plants. So this must be addressed, and if it continues to perform or vibrate in this way, so it will result in fatigue failure in after some time or after certain cycles. Now effects of piping vibration. Piping vibration causes dynamic stresses in a piping system. So dynamic stress is generated due to the piping vibration, and if the stresses are more than the critical value, it will initiate a crack that will propagate slowly and end in the failure of the item in concern. So if this stress is not controlled, then when it reaches some critical value, then it may initiate cracks that may propagate slowly, and finally it will result a fatigue failure of the item. The more fatigue sensitive places are the weld point connections where the branch and header are joined together. Now in addition to this dynamic stress generation, vibration results in wearing of surfaces in contact due to cyclical relative motion between them. That phenomenon is also known as fretting damage or fretting. Now, what are other effects of piping vibration? So, if some component fails, then it will cause downtime of the plant. Then it may cause a serious safety issue due to failure of some items or components of the system. Then you have to correct it because you have to operate the plant. You cannot leave it as it is. So there will be a cost associated with that, that is corrective impact cost, and it may result even environmental impact also. Let's assume that the line is carrying or transporting some hydrocarbons and some leakage happened, and because of that hydrocarbon falls or emits from the pipeline or piping system, which is impacting the environment also. So these are the effects of piping vibration. Now what are the causes of piping vibration? So there are a variety of excitation mechanism that can be present in a piping system and can produce piping vibration. So there could be various reasons which may cause piping vibration in a system, and that piping vibration may finally result in fatigue failure. So some of these common causes are, first is mechanical forces from equipment. We know that in any processing plant there will be various equipments, but majority of the vibration is caused by rotating type of equipments or reciprocating type of equipments. So mechanical forces from equipment caused by excitation forces of reciprocating or rotary equipments. Some examples are like pumps, compressors, reciprocating pumps, etc. Second cause will be pressure pulsations from reciprocating equipment. So there will be centrifugal reciprocating compressor, reciprocating pumps. So where there will be huge pressure fluctuations during their operation. So it can also cause a pipe or piping system to vibrate. Then high frequency acoustic excitations. High frequency acoustic excitations are generated by high pressure drops at relief valves, control valves, or orifice plates. Orifice plates. It is mainly associated with pipe or pipelines that are transporting gas. It is normally not found in liquid systems. Next is water hammer or pressure surge, which occurs due to momentum changes when sudden valve is closed or pump trips. So because of those reasons, water hammer or pressure surge may happen. Then cavitation or vapor bubble collapse due to localized pressure drop. As we know that in pump cavitation occurs. So this type of situation even may occur inside the piping system also, where vapor bubble may collapse due to localized pressure drops. Then due to sudden flashing of liquid, so in the inside the system, if sudden flashing of fluid happens, that also may rise the piping vibration limits. Then periodic pressure disturbances during a flow past the dead end of a branch connection or instrumental item. So if there is a dead end in the system or instrumental item where periodic pressure disturbance also may happen. So all these reasons can provide or can provide can cause piping vibrations. And there is also one of the last but not the least. This is called flow induced vibration. So due to high flow, high velocity flow inside the piping system, your piping system can vibrate. So these are the main causes or reasons for a vibration generation inside a piping system. Now, what are the challenges? Means if you know that the piping system is going to vibrate, then we should address it. But there are some challenges. So what are those? The main challenge is that the design codes, means the piping design codes based on which we design our system, they do not address the vibration issues in a detailed fashion. So what will happen means normally for designing of our piping system, if it is a process piping, we follow ASME B31.3. If it is a power piping, it is will be designed based on ASME B31.1. If these are pipelines, then maybe B31.4 or ASME B31.8. So all these codes does not provide any proper guidelines to address the vibration issue. Because of that, during design stage, normally this remains unnoticed or attention is not given because there are no detailed guidelines. And also in recent times, Operation team increases the flow rates inside the fluids to get maximum output from the piping or pipeline systems within a short span of time. So this increases the vibration tendency, and also one of the major causes in recent times to optimize the cost, there are frequent use of thin walled piping systems. So which in turn reduces the flexibility, increases the flexibility of the pipe and reduces the rigidity of the piping system. So because of which the stiffness of the piping system reduces and piping system vibrates. So these are the major challenges for studying the piping vibration, and because of that during design stage there should be some process by which the vibration can be studied and mitigated. And one of such method is flow-induced vibration study, which we will be learning in next modules. So that's all for this introduction module. Thank you and happy learning.